hope we pray for better days.
Dear students, everything is fine now? All of you are good, okay? Yeah. Welcome back to today's Vidyanagar online science class. Now, I am here with you to continue our 13th chapter, Motion and Time. We will discuss about measurement of time and distance time graph in our today's class. Shall we begin our today's class? Okay. If you did not have the clock, how would you decide what time of the day it is? Have you ever wondered how our elders could tell the approximate time of the day by just looking at the shadows? How do we measure the time interval of a month, a year, etc.? We are going to find answers for all these questions in our today's class. Our ancestors noticed that many natural events repeat themselves after definite interval of times. Like sunrise in the morning, sunset in the evening, and the next day it repeats, right? And a new moon and full moon, etc. also repeats after definite interval of time. Based on these informations, they made some facts. We are going to describe about these facts in our today's class. First one is a day. A day is the time between one sunrise and to the next was called a day. The time between one sunrise and the next was called a day, which means a day was the time interval or time between one sunrise to the next. According to them, one day was the time between one sunrise to the next. What mean a day? What it mean a day? A day was considered as the time between one sunrise to the next. Is it clear? A day was considered as the time between one sunrise and the next was called a day, or it was considered as the time interval between one sunrise and the next sunrise. So that was considered as a day. A day was considered as the time between one sunrise to the next. The time between one sunrise and the next was called a day. Similarly, 1 month was measured from one new moon to the next. 1 month was measured from one new moon to the next. So how was the how they made a definition for the month? A month was measured from one new moon to the next. So it's a time gap between one new moon to the next. As you know it is 15-15. New moon and full moon. So that gap is 15-15. 15 plus 15, 30. So that is 1 month, right? So according to them, 1 month was measured from one new moon to the next. Or it's a time gap between one new moon to the next. A month was measured from one new moon to the next, or it's the time gap between one new moon to the next, right? Just like a year was fixed as the time taken by the earth to complete one revolution of the sun. So it's a time taken for the earth, or the time taken by the earth to complete one revolution of the sun was considered as a year. So a year was fixed as the time taken by the earth to complete one revolution of the sun. Is it clear? So a year was fixed as the time taken by the earth to complete one revolution. So a day is a time between one sunrise and the next. So it's a time gap between one sunrise to the next, and 1 month was measured from one new moon to the next new moon, and a year was fixed as the time taken by the earth to complete one revolution of the sun. Okay. Have you ever thought how the clocks and watches works, or how they measures the time? The working of the clocks and the watches rather complex, but all of them make use of periodic motion. One of the most well-known periodic motion is that of simple pendulum, which means simple pendulum is the best example for the periodic motion. What is a simple pendulum? Simple pendulum means a metallic ball suspended by a rigid stand by a thread. A metallic ball suspended by a rigid stand by a thread, which means the ball made of a metal. The ball made of a metal hanged in a thread with the help of a stand. You can see the picture on the screen. You can see there is a pendulum inside the clock, one thread and a bob, one thread and a ball. So what is a simple pendulum? The ball made of a metal hanged in a thread with the help of a rigid stand, or a metallic ball suspended by a rigid stand by a thread. Or in simple way, the ball made of a metal hanged in a thread with the help of a stand. Okay, a thread and a ball. And that metallic ball is known as bob. What is a bob? The metallic ball of the simple pendulum is a bob. B-O-B, bob. The metallic ball of a simple pendulum is a bob. Okay, as you know, simple pendulum is an example of periodic motion. What is the other name of periodic motion? Oscillatory motion. What is oscillatory motion? To and fro motion of an object is known as oscillatory motion. To and fro motion of an object is known as oscillatory motion. And now we are discussing about the measurement of time. Right. So the time taken to complete one oscillation is known as time period. So what is a time period? Time period is the time taken for the object to complete one oscillation is known as time period. Time taken for time taken by the object to complete one oscillation is known as time period. So how much time requires to complete one oscillation is time period. So in case of pendulum start from the middle and first it goes there, then come back, then to the opposite, then come back. So how much time requires for that process is the time period of simple pendulum. So how to define the time period? Time period is the time taken by the object to complete one oscillation. So how much time requires to complete one oscillation is the time period. Time required to complete one oscillation is known as time period. Clear? How much time requires for an object to complete its periodic motion or its oscillation is known as time period. And the symbol which we can use to denote the time period is capital T. So capital T is time period. Normally we use small t for time, which we use for time, small t. But for the time period you can use capital T. Which letter you can use for the time period? Capital T. And the SI unit of time period is second. The SI unit of time period is second. Just like the SI unit of time also second. So what is SI unit of time? Seconds. The SI unit of time? Seconds. Small s. Yes, S is the symbol for seconds. Okay. And which is the SI unit of time? Seconds. And the larger unit of time are minutes and hours. Which are the larger unit of times? Minutes and hours. The larger unit of time are minutes and hours. And the SI unit of time? Seconds. And what is time period? Time period is the time taken to complete one oscillation. Time required to complete one oscillation is time period. Okay. Then the symbol is capital T and the unit is seconds, and the larger unit of time, minute and hours. Okay. Nowadays, most of the watches and the clocks have an electric circuits with one or more cells, which means the clocks or watches available outside contains cells or batteries. Am I right? They contains batteries, right? Such clocks are known as quartz clocks. Q-U-A-R-T-S, quartz clocks. And they give accurate time. These clocks give accurate time. So, the clocks which contains cells or batteries are quartz clocks, and they give, correct and accurate time. Okay. And as we discussed in our previous class, odometer is used to measure the distance and speedometer is used to measure the speed. Speedometer is used to measure the speed and odometer is used to measure the distance. Okay. And as you know, distance by time is speed. What is the equation for speed? Speed equal to distance by time. That we discussed earlier, right? What is the equation for speed? Speed equal to distance divided by time. Now I am going to teach you two other equations. Like distance equal to speed into time. What is the equation for distance? Distance equal to speed into time. What is the equation for distance? Distance equal to speed into time. And the SI unit of distance is meter. What is SI unit of speed? Meter per second. And what is SI unit of distance? Meter. Okay. So, distance equal to speed into time and the SI unit of distance is meter. And the next one. Time equal to distance by speed. Time equal to distance by speed. And the SI unit of time is seconds. Okay. So, time equal to distance by speed and the SI unit of time is seconds. Distance equal to speed into time and the SI unit is meter, and time equal to distance by speed. Time equal to distance by speed and the SI unit is seconds. Okay. Now we are going to discuss about distance time graph. Distance time graph gives various information about the motion. Distance time graph gives various information about the motion, which means when we compare the graphs, we will get different types of information about the particular motion, like whether it moves in a uniform speed or non-uniform speed. Such type of informations we will get from the graphical representation. Okay, and there are three types of graphs described in your textbook, like pie chart, bar graphs, line graphs, etc. Okay, you can see the pictures on the screen. First one, bar graphs. Second one, pie chart. And the third one, line graph. First one, bar graph, pie chart. And the third one is line graph. And the graph we are going to discuss about distance and time is a line graph. So, which graphical representation we are going to discuss now? Line graph. Okay, as you know, which are the things we have to care while we draw a graph? First, we have to mark two axes, x-axis and y-axis. Which are the two axes for the graph? X-axis and y-axis. So, for the distance time graph, we have to represent time on the x-axis and distance on the y-axis. What we plot on the x and y-axis? We have to plot time on the x-axis and distance on the y-axis. Okay, now we are going to compare the shapes of the distance time graph for the uniform motion and the non-uniform motion. So the shape for the distance time graph for a uniform motion is a straight line passing through the origin. So the distance time graph for a uniform motion is a straight line passing through the origin. You can see on the figure, one line is passing through the center. One line is passing through the 0, right? So that is origin. That's 0. Going through origin, no? So that is origin. So what is the shape of distance time graph for uniform motion? The distance time graph for a uniform motion is a straight line passing through the origin. It's very important for you. Keep it in your mind. The distance time graph for a uniform motion is a straight line passing through the origin. Okay, what is uniform motion? Uniform motion means same distance or equal distance in equal intervals of time. If an object covers equal distance in equal intervals of time, then you get a straight line. Right? If the object covers equal distance in equal intervals of time, you will get a straight line, which means the distance time graph for a uniform motion is a straight line passing through the origin. Don't forget, it's a straight line passing through the origin. Why it passes through the origin? Because it starts from the 0. Right? So the distance time graph for a uniform motion is a straight line passing through the origin. Distance time graph for a uniform motion is a straight line passing through the origin. And what about non-uniform motion? What is non-uniform motion? Non-uniform motion means different distance in equal intervals of time. Unequal distances in equal intervals of time. So if an object covers unequal distances, while we plot on the graph, we have to mark different points, right? Which means we cannot say any particular shape for the graph. In that case, let it be any shape. So the distance time graph for a non-uniform motion is of any shape. Based on the motion, based on the journey, we will get any shape. Maybe curve, maybe any other shape, maybe it go like and come down, then again go up. So we can say just any of shape. So the distance time graph for non-uniform motion is of any shape, and there is only one shape for the distance time graph of uniform motion. If the motion is uniform, definitely you have to get a straight line, because there is only one shape for this graph. Distance time graph for a uniform motion is a straight line passing through the origin. The distance time graph for non-uniform motion is of any shape. Okay, so time on the x-axis and distance on the y-axis, and the distance time graph for the uniform motion is a straight line passing through the origin, and the distance time graph for the non-uniform motion is of any shape. Clear? So it's time for us to conclude our today's class. I hope you got it, the points. Watch the video carefully, try to understand the concepts. We will meet you soon with another video. Until then, it's bye. Thank you for watching. Have a great day ahead.